Cheers. Thank you, everyone, for the opportunity to talk today. And I'm just going to take on a bit of a journey of what I've been trying to discover about this topic over the last wee while. The potential effects of these PV solar farms on waterbirds in New Zealand. So I'm going to talk primarily about ground-based PV solar farms. There's different types of solar farms around the world, and they have their own issues and things like that, but I'm talking about just about every solar farm in New Zealand that's planned or being built as a ground-based PV solar farm. So I'm talking specifically about them. And I'm just going to go through the sort of exploration of what I've been trying to figure out about risks for birds. And when I started this work, I was just asked to evaluate some potential solar farm cases, and I thought, and they said, are there any effects of birds? And I said, oh, I don't think so. I don't know. But anyway, Google told me differently immediately, and I'll take you through that. So there's information from overseas on bird collisions in particular with PV solar farms, and then I'm going to talk towards the end of the talk about what those implications might be for our New Zealand birds, and hopefully through the presentation you'll see why it's relevant in particular to our braided river birds. So it turns out New Zealand's a great place for solar farms. All the sort of bright orangey places, a lot of the North Island, a lot of the South Islands, particularly in the east, has really good solar irradiation, and pretty much anywhere that's orange or dark yellow or red is up for, is a good place to go. And I don't know if you're all aware or not, but there's just basically incredibly dramatic growth in the proposals for these PV solar farms in New Zealand. At the moment, I know of about 50 proposals over recent years, and these are what I'm calling industrial scale or utility scale PV solar farms that have generating the proposals of anything from 50 megawatts up to 500 megawatts. And if you add up all the proposals that actually for the various planning things, fast track, RMA, etc. at the moment, they would generate pretty much about over 8,000 megawatts, which is actually about the most that we generate now anyway. So if all of these PV solar farms were built, they would double our power capacity, generation capacity. And that's just the ones that are existing proposals. That cover something like 12,000 hectares of places in the country, and there's sort of needs somebody in China to build more than 13,000 panels, which has its own sort of story behind it. So when I started looking at this, there was sort of no mention of birds with the New Zealand, quite a few of the early PV solar farms. When I started looking, I found out that there's actually heaps of global guidance for, I guess, biodiversity impacts and dealing with biodiversity and things like that. There's heaps of guideline documents that have been around for well over 10 years. Two of the main things that they come across, or that they all say, is that don't build your PV solar farm near a significant waterbird habitat, because there's potential impacts there of habitat loss and impacts on the birds. Then they all say to be worried about collisions of birds, particularly waterbirds, with PV infrastructure. So kind of to get you in the mood, here's a quote which sort of, I guess it reflects the surprise I felt when I started looking at this. And maybe Greg should read it because he likes reading slides, but it's, American solar farms have a bird problem. Utility companies have been finding bird carcasses littering the ground at their facilities for years, and it's a strange and unexpected consequence. No one is sure why this is happening, but it's clearly a problem for an energy sort of industry that's said to be environmentally friendly. And another one from the California Energy Commission, which done a big study of this, where they said many stakeholders became concerned when dead birds were unexpectedly discovered, etc. This was surprising because there seemed to be no obvious threat to the birds from the panels. And they're especially surprised because some of these facilities are getting water birds, and quite often there wasn't much water around either. So it's a bit of a mystery. So quite a few people focus on that there can be benefits from creation of solar farms for birds, and that's usually the first thing that people rely on when the issue is raised. And there's plenty of publications on this, but it's more revolving around situations where you have grassland birds that are in agricultural systems, which are, monocultures and things like that. You build a solar farm, and you can enhance the grassland habitats for all sorts of species. You can plant, sort of paddocks or mixed grasslands, all sorts of habitats under those, and that happens. And when that happens, lots of bird numbers increase. But it's mainly the sorts of things that were introduced to New Zealand that we don't seem to care about too much. So things like sparrows can do really well if you enhance the habitat at a European solar farm, which is a good thing because lots of these species are quite threatened in those places. But just sort of moving on to the data on bird fatalities. This first paper, Kagan et al., was the one that really sort of noted that there's 48% of these collisions were from waterbirds, and then when I got involved, I started looking at these papers like everyone else does, and found out that there's a few studies published, but most of the data is just not there. There's a study that I'll talk about from this guy Smallwood from California, which is where most of the analysis comes from. And the reason why that study is well documented is only really because California has a really good Official Information Act process, whereas most of the states don't. So quite a few of the solar farms in other parts of the states, they monitor bird collisions, but none of those data are available to anybody to actually analyse. So anyway, this Smallwood, extrapolated some of these fatalities from 156 different bird species which were colliding with the solar farms, and you can see the figures there, sort of 140 to 125,000, 141,000 a year birds that were being found collided with the solar infrastructure. What sort of birds were in the fatalities from California? Again, lots of passerines, the perching birds, which are the commonest things out there. But the second biggest group, over 30%, were waterbirds. And then basically there's a whole range of the sort of different types of birds colliding with these solar farms. So because it's sort of relevant to New Zealand and threatened waterbirds, and especially if you start putting your solar farms by a braided river, I started looking at Smallwood's data in a lot more detail, and found it as one of the first things that came out was that there were lots of waterbirds colliding with infrastructure, but it was highly variable from site to site. So there's one solar farm there which has a huge number of 70% of the collisions were waterbirds, whereas other ones have a smaller amount, even down to 5%. So there's something going on about why do some solar farms have a lot more waterbirds colliding with them than others, and that's a mystery, and that's something we just got to really think about in New Zealand when because all these solar farms are in different situations and locations and stuff. So if we kind of figure out what the collision risk is that it's going to be highly variable site to site. Another thing I looked at was just the cause of death from the different things, and again, it's highly variable what people record as a cause of death, but on average, 44% were collisions of some sort, 21% of them were entangled in things like fences and wires. So things like tall security fences around these solar farms are quite a risk for them, or the wiring that crisscrosses it, so transmission lines and things like that, resulting in things. It's interesting too that one of the common causes of death is predation, but I think that's probably confounded with collisions as well, because if you collide with a thing, if you're a dead bird or an injured bird or a stunned bird, you're probably going to be much more vulnerable to predation by birds of prey than you would have been if you were flying through at speed and not. So the last sort of biggest cause of death was electrocution, so that's from exposed wiring and things like that. So that's immediately the sort of thing we can deal with in New Zealand. There's no excuse for exposed wiring in a modern solar farm, so hopefully we don't see that happening, or we'll try and get it so it doesn't. And then there's a lot more data on which elements of a solar farm where these birds are being picked up. So again, highly variable from site to site, but most of the collisions on average are around the PV arrays themselves. There's 24% of them are around transmission lines, so that's pretty important, and about 10% were on the security fences. So what sort of waterbirds are colliding here? So this graph is a comparison from a paper by Conkling et al., which is comparing the composition of fatalities between PV solar farms and wind farms in California. The yellow bars are different families of waterbirds. And interesting there immediately was there's a lot more waterbirds colliding with PV solar farms than colliding with wind turbines, which I think is quite a dramatic difference between the two sorts of energy things. And then the sorts of birds, well, there's 15 species of waterfowl colliding that were recorded in the study. A lot of 5 species of grebes, and again, second most common waterbird that was colliding over there were grebes. And the biggest group, interestingly, were rails. So things like crakes and the bigger rails were turning up with collisions, to a high degree. And then all the other waders, 8+ species, herons, including 2 species of bittern, gulls and terns, and the terns include black terns, which is a marsh tern, related to the black-fronted tern, and the 2 cormorants were turning up as well. The other thing I had a quick look at was what, when through the year these fatalities might be happening, and luckily there was a paper on that which showed that the 2 blue bars are things that are defined by Kosciuszko et al. As water associates and water obligate species, but you can see that the fatalities occurring throughout the year, but most of them are happening in the autumn, and that's probably during the bird migration seasons when they're extra mobile and zooming around the environment. So this study by this guy Smallwood, he actually worked out waterbird fatality rates per megawatt of solar generation. Now, you can read this graph to your heart's desire on the website after the talk, but don't get too hung up on it. But what it's doing is it's showing that there's a bunch of all the waterbird families were colliding with PV infrastructure. And when he looked at it per megawatt of generation, you can see that there's quite variable results. But if you start to think about that in terms of what, say, a 500 megawatt generating solar farm might kill, well, in California, you'd predict it would kill something like 28 waders a year, if you extrapolate that out, or 450 rails, or you know, 8.5 bitterns. I don't know what happens to the other half of the bitten, but so if you start to think of these big industrial scale things, if you're getting that sort of collision rate, then they can plausibly equate to population scale influences. And if you're thinking about New Zealand species, some of our species are incredibly rare or uncommon. You know, if that sort of collision rate happens, can it be sustained? Now, just stop talking about all the dead birds for a second, but the other mystery about this is nobody knows why birds are colliding with the solar infrastructure. There's a bunch of theories that haven't got much, there's not much known about them really, but it's primarily probably because birds have totally different vision to humans. They've got 2 extra cones in the eyes, they can detect UV light and polarized light, which we can't do. And you know, one of the popular theories that people have looked at overseas is this thing called the lake effect hypothesis, where simplistically people think, oh, if you see 500 hectares of solar panels when you're flying by, you might mistake that for water. It could create a big super stimulus, and that might account for collisions. It's probably much more complex than that, because there's actually not great support for this lake effect hypothesis, but a couple of things I've been looking at are things like birds use polarized light to navigate with. They use it for migration, they use it for orientating themselves, they use it for calibrating their magnetic clocks and things like that. So if you're creating this huge, I guess, mass of polarized light in their flyways, then that could be confusing them. Well, there might be something else going on. You know, people just simply don't know really why this happens. The thing about this polarized light is that, I mean, a modern PV panel is designed to absorb light, of course, but a couple of studies I've seen from overseas, they're still saying that it's reflecting a lot more polarized light than the surrounding habitats. So if you put a solar farm by a bunch of water, both of which are reflecting polarized light, the PV farm will still reflect about 80% more polarized light than the natural water body beside it. So there might be something like this. It's a sort of question I keep asking people. So how much light gets polarized off your PV panels? How much can you reduce that amount of polarized light by designing anti-reflective coatings that are bird sensitive and not human sensitive? Okay, so, you know, there's basically a bunch of risks that in the literature from overseas that are saying there's just direct habitat loss from when you build your solar farm. You can get collisions during construction have been recorded when people are building the infrastructure. There's degradation, habitat loss, etc., etc. Permanent or temporary displacement of birds if it's a habitat they're using. And then through ongoing operation, the collisions with fences, cables, transmissions, solar panels, and electrocution. Okay, so what's all this got to do with us in New Zealand? Because that's all from overseas. And the overseas data are very limited because most of it's not available publicly. And there's literally no data from here on any of those issues at all to make valued judgments on. Some of the overseas studies are obviously in different habitat types. They've got different species that are being killed. But in New Zealand, there's a lot more. One of the things that people were saying overseas is that solar farms, the collisions are there, but they're small compared with wind farms and other sources of death. But they're also, the American stuff in particular, like it doesn't really involve a bunch of threatened species like we have here that have very small populations and therefore are potentially much more vulnerable. We do have all the same sorts of birds, the ecological equivalents in New Zealand of all the birds that are turning up frequently in those limited collision literature. So I think we have got, a real cause for concern, but still not sure what to do with that cause of concern. The other thing is that, which I think all the overseas stuff is ignoring so far, is that most of the collisions are probably happening at night. And what we've learned in recent years through the GPS tracking studies of birds is that they're much, much more vulnerable than mobile than we imagined. They're zipping around the landscape all the time, and especially at night. And this is just an example of, one female bit in 20 days in Northland, 30 wetlands, 200 kilometres, and all flying at night. So that's when they're potentially much more vulnerable to collision risk. There's a big American study that people are all talking about at the moment where they've monitored all this daytime use of birds and had no collisions out of 70,000 observations or something. But none of them are looking at night. And yet that same study, they're still reporting bird collisions. They just don't know when they happen. Seems a bit telling. So here's a real example from one of the proposed solar farms in the Mackenzie country, and this is tracking data from 36 black-fronted terns. Underneath that massive dots, which are 3,500 fixes over 15 months, is a proposed solar farm. And if you look at this next slide, most of that activity is happening through the night or at dusk, sunset onwards, and so on. So going out and doing a daytime survey is not much use for determining what that risk profile might be. So the work I've done so far has just opened up many, many questions. And, there's the fundamental questions for here are, will birds in New Zealand with the modern solar farms, will collisions occur here? And what, if so, who might collide? And that is a complete knowledge gap. But based on the overseas stuff, it calls for concern. And then there's all sorts of other stuff. Don't read this, when you're sitting in front of the fire tonight or tomorrow when it goes on the website. But there's so many factors that might influence collision risk, but to do with the environmental factors, the wind, the rain, the sun, the time of day, migration behaviour, seasonal movements, depending on where you are. There's a whole lot of stuff about the actual solar infrastructure itself, which may make things more or less attractive. And there's a lot of stuff that could be looked at, but it's just a massive open question. And things like, how you configure your solar farm might reduce that risk by doing things like this photo here, where all the panels are stowed 90 degrees at night in this picture, so that reduces the reflectance into the sky at night if there's moonlit, or at dawn and dusk when you have the low light coming through. These are all possibilities for mitigating these effects, but none of them have been tested globally. So it's a complete knowledge gap that we have to deal with. So just to conclude, we're dealing with extreme uncertainty here, and we're dealing with having to infer information from overseas that may or may not be relevant. But it's such a challenge to deal with this sort of level of uncertainty, where impacts could be anything from negligible to catastrophic, depending on where you are and what you are. So that's a challenge, a really big challenge for us all. Three slides with knowledge gaps for years of research, but the trouble is, the scale of the farm developments in New Zealand has already outstripped our knowledge, exponentially. There's 50 or so on the books of these big things at the moment. There's more to come. So how do we deal with this issue? And it's clear, at least from overseas, and I can see for New Zealand, if you're looking at the risk, doing a risk profile, that it's really relevant for our waterbirds and our braided river birds. And so we've just have to deal with that in a rigorous, delightful planning world. And just about every paper, and you'll find plenty of papers on this topic overseas, they all call for research, but again, to understand why birds might collide with these solar farms, because if you understand why, then you can actually start to think about designing some solutions. If collision rates are similar or greater than what has been recorded in California, then there will be population scale effects. If you put your solar farm in a really controversial place, like has been proposed around the Kaki sites at the moment and the ferry turn sites in Northland. And you can come up with some potential mitigation solutions for all of these things. That's great, but they're all experimental. So we don't really know if any of them would be effective. I mean, ultimately, we've got to monitor collision rates at these solar farms, but that itself has quite a problematic risk with it, because, you know, if you measure it and there's negligible collisions, that's a great outcome. But if it's the opposite of that, then, yeah, what do we do? Do we start dismantling solar farms? I suspect people wouldn't have an appetite for that. Yeah, so in the meantime, I think we have to, you know, take the international guidance and be precautionary about it. Don't build your solar farm by a really significant, important bird area or a wetland or on the side of a braided river or on a mobile species flyway where there's birds zipping around at night like crazy. Thank you.